Hello everyone. Today we are going to solve one numerical for the analysis of helical gears. In this problem, 20 teeth pinion is meshing with 100 teeth gear. The speed of rotation of pinion is 720 rpm. The normal pressure angle is 20 degree while helix angle is 25 degree. Face width is 40 mm and normal module is 4 mm. Both pinion and gear are made up of steel having the value of ultimate strength as 600 megapascal or 600 Newton per mm square. Both of these components are heat treated so that they achieve a surface hardness value of 300 bhn. The service factor is 1.5, the factor of safety is 2. We have to consider that velocity factor accounts for the dynamic load. It will give us the equation and answer for dynamic load, and we need to calculate the power transmission capacity of these gears. So as per our usual practice, first of all we will sort the given data so that our problem solution becomes simplified. So the given data is number of teeth on pinion ZP, it is 20. Number of teeth on gear ZG, it is 100. The pinion rotates at a speed of 720 rpm. Remember, this is a helical gear arrangement, so that's why we will also need to calculate the virtual number of teeth. Then normal pressure angle alpha n, it is 20 degree. Helix angle psi, it is 25 degree. Then face width B, it is 40 mm. Normal module is 4 mm, so Mn is equal to 4 mm. Both pinion and gear are made up of steel. The value of SUD, it is 600 megapascal or 600 Newton per mm square. The value of surface hardness, it is 300 bhn. Service factor CS is equal to 1.5. Factor of safety is equal to 2. So if we are talking about velocity factor, which means we need to calculate CV. And to calculate CV, we need the velocity, and these parameters are still not known. So now we will proceed towards this solution. So first of all we will calculate, like I just said, because this is helical gear, so we will need virtual number of teeth so that we can use Lewis form factor. So virtual number of teeth, it is indicated by ZP dash. It is given as ZP divided by cos cube of psi. So ZP, number of teeth on pinion, it is 20. Cos cube of psi means cos of 25, which is the value for psi, and cube of that entire entity. So that gives us ZP dash. It is equal to 26.87. On the basis of this value, now we will select the value of Lewis form factor from this data table. Just give me a second. Yes. So we see that the value that has been obtained for ZP dash, it is 26.87, and it is between 26 and 27. It is greater than 26 and it is less than 27. So either we can directly consider this as 27, but every time this may not be the scenario. So let us understand how to proceed if it is not very close to 27. So we will proceed with the help of interpolation. We have already learned this in the subject of numerical methods, so we will keep it simplified. On x-axis, the known values are written. So known values are 26, 27, and there is this 26.87. It is not necessary to draw this graphical representation in the examination. This is just for your understanding. If you replicate this in your examination, it will not take more than 30 seconds or 1 minute, but it will ensure that your answer does not go wrong at any point of time. So for 26, let us call the values of Lewis form factor as y. So correspondingly, let us say this is x1, this is x2, and this is x3. In the same way, let us say we will write y1 here, y2 here, and y3 here. So y1 is the value of Lewis form factor when the number of teeth zp is equal to 26, and it is here for 26. We see that the value of Lewis form factor is 0.344. For 27 teeth it is 0.348. so y1 for 26 it will be 0.344. y2 is not known to us, so this is unknown. On the other hand, y3 it is 0.348. This is known. So we will not go into the complicated formula. Actually, it is a very simple concept. It's just the slope of the line considering linear interpolation. So the formula is y2 minus y1 divided by x2 minus x1. It will be equal to y3 minus y1 upon x3 minus x1. You should notice one thing in this case is that in this entire expression, this y2 is the only unknown quantity. All the other quantities, they are known to us, and that is why we can solve this equation. Let us substitute the values. So y2, which is the desired value of Lewis form factor, the unknown entity. Okay, y1 0.344. Then x2 26.87. x1 is 26. This is equal to y3 0.348. y1 0.344 once again divided by x3 27 and x1, this is 26. Okay, so now when you solve this equation is pretty simple. So ultimately you will get the value of y2 as 0.3475. So this is the value of y2, or simply this is the value of Lewis form factor that we need in our analysis. So we have obtained that value when virtual number of teeth it is equal to 26.87. So we will proceed with that now. So on the basis of this interpolation, you can write down that interpolation in here. So ultimately the value of y is equal to 0.3475, corresponding to the value of z dash p equal to 26.87. So now capital Y is there with us. Then we can proceed with the beam strength approach. Our thought process is that we will calculate the beam strength as well as wear strength, and then we will decide how to proceed for the design of the gear. And as we know, I will simply write it down in a corner for the thought process. SB, the beam strength, it is nothing but for a helical gear, it will be Mn B sigma B Y. So right out of these, we have found out Y. We will need other parameters. So firstly Y is there, then the value of sigma B, as we know from our previous understanding, it will be equal to SUT upon 3. So that will be simply 600 divided by 3. So that is equal to 200 megapascal or 200 Newton per mm square. Then the value of B, the face width, has already been given. So now we can proceed with the value of SB. So that is Mn B sigma By. So I will again put down the formula here, Mn B sigma By. So Mn is 4 mm, B is 40, then sigma B we have just calculated, that is 200, and capital Y it is 0.3475. You put all of these entities in your calculator, you will get the value of SB as 11,120 Newton. We will save this value. We will put a bracket around it so that afterwards we will be able to locate it. Okay, now this was on the basis of beam strength. Now we will need to calculate another entity, which is wear strength. Now we will go for this. Simply I will put down the formula. The expression of wear strength, it is equal to, remember this is again for a helical gear, so that will be equal to BQ dpk divided by cos square of psi. Now we will determine individual parameters. Already B is available with us, so now we will proceed for the calculation of Q. Q is nothing but your ratio factor, so that is equal to 2Zg upon Zg plus Zp. These are values which are known to us. So 2 into number of teeth on gear, it is equal to 100 divided by 100 plus number of teeth on pinion. Remember, this is Zp, it is not Z-P. The function of Z-P is finished. So ultimately, on the basis of this, just a second. So ultimately, we get the value of Q as 1.667. This is an important input for our next step of solution. Q is available. Now we will proceed with the value of dP. So the value of dP is given as Zp mn divided by cos of psi. So Zp number of teeth on pinion, it is 20, normal module, it is 4 mm divided by cos of 25 degree. So that gives you 88.27. This is the value of dP. The second input which is necessary for our solution. Okay, the next entity that we need to calculate, the value of factor K. And because in this case both gear and pinion are made up of same material, and that is steel, so that is why we can proceed with the formula of K as 0.16 into BHN divided by 100 bracket squared. So ultimately, when you substitute the values, what you get is 0.16 into the value of BHN is 300 divided by 100 bracket squared. So ultimately, the value of K, it will be equal to 1.44 Newton per mm square. Okay, excuse me. So the value of K is 1.44. Now the next thing, that we already have the value of B, we don't need to go ahead with that. Then we don't need to calculate that. We have Q now, we have dP, we have K, we have psi. Now we can proceed with the calculation of wear strength. So it means that SW is equal to the face width, it is 40 mm. The factor Q that we just calculated, it is 1.667. dP is 88.27 multiplied by the value of K, it is 1.44 divided by cos of psi, so that is cos of 25. So when you substitute all of these values in your calculator, you get the value of SW as 10,318.58. So now, why we have calculated the value of SW and why we have calculated the value of SB. So from these two observations, from these two values, we observe that the value of SB is greater than the value of SW. So it means that when the gear arrangement, the pinion and gear arrangement is subjected to the loading or whatever the power it is transmitting, first of all, it will fail because of its wear strength consideration. And that is why, in this case, wear strength is definitely lesser than the beam strength of this arrangement. And that is why wear strength will be the failure criteria, or seems, simply we can write as a technical conclusion, SW is less than SP. So it means that wear, or what we call as pitting failure, is the criteria for design. It is our design criteria. Okay, so whatever we will do, we will calculate with reference to this value now. So the next step in our calculation, firstly we will need the magnitude of velocity, because we will need the velocity factor. So to calculate the velocity, V is equal to pi dp np upon 60 into 10 raised to 3. We already have the rotational speed of the pinion, that is np, so we can proceed with this pi. Then the value of dp that we just calculated, 88.27, np is 720 rpm, divided by 60 into 10 raised to 3. You substitute the values in your calculator and then you obtain the value of velocity as 3.33 meter per second. Okay, now once you have this, immediately you can calculate the velocity factor. And as we know, the velocity factor for a helical gear is simply given as 5.6 divided by 5.6 plus square root of V. And it is not like in the case of this spur gear that there will be different velocity, and that's why there will be different formulation for CV. So that's why the value of CV will be available here. So 5.6 divided by 5.6 plus square root of 3.33. So the value of CV will come out to be approximately 0.7543. Okay, so now we have the value of CV as well. Now we can proceed for the calculation of tangential force with the help of these equations. Our basic understanding is that the most fundamental understanding on the basis of which all these equations or all these processes are developed is that whatever is our failure criteria, in this case it is SW, it should be, whatever is the wear strength, it should be greater than the effective loading which is coming on this gear system. And if we want to remove this particular sign of greater than, then ultimately we need to balance the right hand side of the equation. So to balance this, ultimately what do we get? SW is nothing but CS PT upon CV. Also we should be accommodating the factor of safety in this case. So now, because CS PT upon CV is our P effective and FS is the factor of safety, so now the service factor, it is 1.5. PT, the tangential load, is not yet known to us because power is not known, that's why torque is not known, that's why this tangential loading is not known, tangential force is not known. Factor of safety is known to us, it is 2. Then the value of CV, just we calculated that from here, so that is 0.7543. So SW, sorry, I forgot to write one thing here. So if we want to balance this, SW should be equal to P effective into factor of safety, and then it translates to this equation. Okay, then In this entire equation, yes, we also have the value of SW with us. We have just calculated that, and just a second, that value is 10,318.58. So 10318.58 is the value on the left hand side. Now this is one equation, one unknown scenario. The only unknown is PT. So from here we get the tangential force which is acting on this gear, PT. It is equal to 2594.43 Newton. So that's the tangential force which is acting in this gearing system. Now because we have the tangential force, we can go ahead with the torque transmission capacity, or the torque which is transmitted. So ultimately what do we get is MT, the torque transmitted. It is equal to whatever is the force and the distance through which the force is acting, PT into dP by 2. So PT, it is 2594.43, and then dP by 2, so dP is 88.27 divided by 2. So ultimately MT, when you calculate this, it comes out to be 114505.39 Newton mm. Okay, so now we have MT. Immediately we can calculate the power transmitted. So that is equal to kW. So this is our general formula: 2 pi, the speed of rotation of pinion, into torque transmitted, 2 pi nmt, divided by, because we want to convert this into kilowatt, so 60 into 10 raised to 6. So now kW, 2 pi, the speed of rotation is 720, then mt, it is 114505.30 divided by 60 into 10 raised to 6. So the final answer, the power which is transmitted because of this particular gearing system, it is 8.63 kilowatt. That's your final answer. So I hope this was useful to you, because this was a fundamental numerical in the analysis of helical gears. Remember, our understanding was very simple. We just needed to know whether SB is greater or whether SW is greater. So whichever is greater or whichever is smaller, in that case, simply we would proceed in that direction. So the formula of SB was known to you, that is MNB sigma Vy, and formula for SW, it was also known to us, that is P cube dpk upon cos of psi. So upon cos square of psi. So ultimately we evaluated all of these entities. We reached upon a conclusion that something is greater than the other entity. So let us say if SW is the design criteria, then at that point our focus is that SW should be greater than the P effective. Then we did the splitting of P effective into its individual components so that we can arrive at PT. When we arrive at PT, immediately we can arrive at MT, and then we can arrive at the value of power transmitted. This was the flow of our logic. So I hope this video was useful to you. Thank you.